Start recording. All right, guys. Recording starting. We're gonna go ahead and start chapter 3. So remember, we're doing test 1 review, and finally some students were realizing, hey, we haven't done that yet. Well, my apologies, guys. I kind of started the review a little too early. The test won't be due this weekend. We have to finish covering chapter 3 materials before we do test 1. So my apologies on Monday's class. It was a busy weekend with everything, and because I'm creating a new class online, and there's a test after 2.6, so I confused that new class with this class. So my apologies for that, guys. I'm glad some of you guys noticed the difference, that we haven't covered it yet. So that's awesome. All right, so let's go ahead and jump into chapter 3, guys. 3.1. I don't have a headset, so I am very sorry if you hear kids yelling and whatnot. I do have 2 boys. One's at school though. One is a 3-year-old being watched by his grandmother. So they're in the other part of the house. So just want to apologize in advance. Okay. So if y'all couldn't hear something or it was cut off, just either type it in the chat or let me know, and I will gladly re-explain it or help you guys out. All right, so we're in 3.1, simplifying algebraic expressions. So before we get into it, what is an algebraic expression, right? So recall, an algebraic expression is a combination of numbers, letters, which are variables, and operating symbols. Operating symbols are pretty much like different operations, right? Like addition, subtraction, multiplication, division. We're going to stick to those 4 for now. And then we have a note. Note is terms of an expression. Well, first, what is a term, right? Well, a term of an expression is separated by a plus or a minus sign. So that's what terms are, right? Because there's different terms. Now, before we get into the math, there's one more definition I want to go over. And the definition of a constant term is just a term that is a constant or a number. So like 7 is a constant term. -12 is a constant term. It's just pretty much something that's a number, right? That's a constant term. A variable term is a term that contains a variable. So for example, a variable term is like 2x or 5y squared or -10z. Those are all variable terms, right? Because they carry a variable, right? And the last definition is the numerical coefficient. It's the number factor of a variable term. So the numerical coefficient is the number factor. So how does that look like, right? Like for example, let's take 7x. The numerical coefficient is the 7. Because it's a variable term because there's an x involved, but the 7 is the numerical coefficient, right? It's the number factor of a variable term. Now, another example of numerical coefficient is 5a. The coefficient of that is 5. Pretty much numerical coefficient is just a fancy way of saying the number next to a letter, pretty much. Are there any students that needs extra time writing down this slide, guys? Any extra time at all? Type in the chat before I move on. Okay, I'm gonna go ahead and add 2 minutes to the timer, and then we'll move on. And now if you finish before the 2-minute timer, just type in the chat that you're done, so I can either ask again or move on. Thank you, Jacob. All right, anyone need more time? We're about 20 seconds left. All right, I'm gonna go ahead and move on. So here are some examples of terms, guys. X plus 3, 3y squared minus 6y plus 4. Can someone tell me how many terms they think they are with x plus 3? How many terms do you see here? 1, 2, 3. Now, if you don't know what a term is, just look at your notes. What did we say a term is?
2.
There are 2 terms with x plus 3. That's correct. The x and then the 3. Can someone tell me how many terms are in this expression down here? 1, 2, 3, 4, 5. How many terms does everyone see for the second one, the bottom one?
3.
3 terms. Good. Remember, because the terms are separated by plus and minus sign, guys. Plus or minus sign. That's when we indicate a different term, okay? Any questions so far?
No.
All right. Now, there will be expressions where terms have like terms, right? So what is a like term, right? A like terms have the same variable factors with different coefficients. So pretty much they have the same letter, the same exponent and everything. So I'll give you a moment to set this up into your notebook and then you create this little chart into your notes as well. It separates you, it shows you example of a like term and example of unlike terms. There's a minute left on the timer before I move on. Now, please, I'm emphasizing again, write everything that I have on my slides unless I tell you not to write it. I had a student reach out to me from last semester. She's taking college algebra now, and she thanked me for the notebook. She says her notes from this class have helped her with the next class, and she just wanted me to know. So, all right, that was 2 minute timer, guys. Would anyone like additional time to write this slide down? All right. And we'll go ahead and move on. If you do say yes, I'll move back. So now, before we get into some mathematical examples, let's go ahead and write down a distributive property. This was where. So what it's saying is if A, B, and C are numbers and AC plus BC is equal to A plus B times C, or equals to C parentheses A plus B. So we can have it either after the parentheses or before the parentheses, okay? Go ahead and give you guys a couple minutes to write this property down. So what that's saying is whatever numbers on the outside, the C just gets multiplied to everything inside, right? C times A is AC, C times B is BC. Excuse me. All right, anyone need more time for this slide? Okay. Here's example one. I'll go ahead and give you about a minute to set it up into your notebook. Now, example one says simplify each expression by combining like terms. Now remember, in order to combine like terms, they need to have the same variable factor. So the same letter and the same exponent. So look at A, 4x plus 6x. Are those like terms, yes or no?
Yes.
Yes, it is. So 4x plus 6x is 10x. Could we combine? It's like having 4 apples plus 6 apples gives us 10 apples, right? But instead of apples, it's the letter X. Look at B. We're combining like terms here. They're both Y's, so they are like terms. What number is invisible in front of this Y class? Anyone remember?
1.
1. There is an invisible 1 class. That is correct. If you have 1y minus 5y, then it's going to be negative 4y. And then we have C. 3x squared plus 5x squared minus 2. There's 3 terms there. Can anyone tell me which terms we can combine? Can we combine all of them? What do you think?
We can combine the x squared, the 3x squared, and the 5x squared.
Excellent. That is correct. We can combine both 3x squared and 5x squared because they both have the same variable factor. So 3 plus 5 gives us 8x squared. Notice how we only combine the numbers, the 3 and the 5. All right, practice 1, guys. I'm gonna go ahead and give you guys about 2 minutes to write these down and combine them yourself. 2 minutes starting now. All right, for practice 1, guys, anyone want to share what they got for A? We got a negative 6m from 3 students on the chat. Sarah agrees with it. And I want to tell you guys that I also agree with it. Good job, class. On B, count of three, I want you to type in your answer for B on the chat. On three, press enter. 1, 2, 3. What did we get for B, class? What did we get for B? I haven't looked yet. Oh, crap. My bad. My apologies. For B, we have 7A. Excellent, class. Excellent. And we got 7A. That is correct. Now, for C, now to write an exponent on typing, I'm gonna show you how, I'm gonna give you an example how to write an exponent on the chat. So you put like 4x and then you use the little caret symbol next to 6, 4x, that's 4x squared as a chat, you know. So I'll give you a moment to type out your answer for C. Give you an answer, a second to write your answer for C. Now, before I tell you to type it in, what number is in front of the C? So the Y, it's negative Y squared, right? What's the answer? What number is invisible in front of that Y? A -1, right? So count of three, let's go ahead and put in your answer for C. Go. All right, all right. So we have a couple different answers, right? We have so we combine the numbers. What number is invisible in front of that Y? It's a -1, right? So you owe me 1, but you have 3, so you have 2 left over. But notice how it's 2y squared plus 7. So make sure we don't change the exponents up. The exponent stays the same. Because I did see a student write a 4 instead of the 2 for the exponent. Nothing changes with the exponent, just the coefficients. Okay, we combine the coefficients. All right, great job, class. Let's keep going. Now, these are properties of addition and multiplication. I'm gonna give you guys about 5 minutes to write these down real quick into your notebook. Now, the reason why I'm having you write these is these are actually properties that are kind of universal. You'll use them for this class, the next class, for all mathematics, actually. As the properties of addition. And I'll talk about them once I give you time to write these down, okay? All right, I'm gonna read over these properties and then ask if anyone needs more time. So look at the properties of addition and multiplication. Look at, and then, so the goal of this class of these properties of my notes, as we move forward, I hope that you're able to read some of these properties in the future classes and understand them from your growth in this class. So let's look at the first property here. So properties of addition and multiplication. If A, B, and C are numbers, then A plus B equals B plus A, which is called commutative property. So what does that mean, right? What's going on? So commutative property tells us that if we have 2 plus 3, that is going to be the same thing as 3 plus 2, which just gives us 5 at the end of the day. So commutative tells us doesn't matter the order we're adding in, because we're going to get it the same result at the end. Look at the commutative property of multiplication, saying A times B is the same thing as B times A, just like 4 times 5 is the same thing as 5 times 4, which is just what? 20. Now look at the next half of the property. That is the order of adding or multiplying two numbers can be changed without changing their sum or product, which is what we just showed right here. Now, these properties, the associative property of addition is saying that we have three different numbers. It doesn't matter which order we add the numbers. We can add the first two numbers and then add the third one, or we can add the last two numbers and then add the first one. We'll get the same result at the end. So this is talking about the grouping of numbers in addition can be changed without changing their sum or product. So sum is the answer of an addition problem. Product is the answer of a multiplication problem. Helpful hint. Examples of these properties are, and they give you examples with actual numbers. Now look at the second bullet here. The second bullet says these properties are not true for subtraction or division. So only for addition and multiplication. That's why I'm having you guys write this down. Would anyone like additional time to write the information from this slide anymore? Any more time than I given? I know it was a lot of information. I get it. I'm gonna go ahead and add 2 minutes and see how that goes for everyone, okay? All right, that was the 2 minute timer. Would anyone like more time than 2 minutes, guys? No worries if you do, just asking before I move on. Last call. Anyone need more time? All right, I'm gonna take this silence as where everyone's good to go. And I remember there will be a video on this lecture as well. All right, example 2, guys. I'll give you about a minute to set this up before I jump into it. All right. Example 2, simplify. So we simplify combining like terms, class. So in this example, can someone tell me what are some like terms we can combine?
The 2y and the 4y.
Excellent. So I'm gonna underline the 2y and the 4y. 2y plus 4y is 6y. Can I combine anything else, class? Any other like terms, or do I just bring down the -6 and the 8? Are those like terms, guys? The 6 and the 8? What do you think? Yes, we can combine. Now they are different, Kayla. They are different, but they're the same in the sense of they're both numbers. So I'm gonna underline it twice. This is how I break down. This is a technique that I use, class, for combining like terms. Is one lines can combine, the two lines can combine. Now, Kayla's not wrong that they're different, but they're both numbers though. So we could combine numbers. So one thing that my teacher used to say for combining like terms kind of sticks to my head is numbers with numbers, y's with y's, x's with x's. So just to help me remember, it's a little jingle that I now remember to this day. So -6 plus 8. I owe 6 to my bank because it's -6. I put $8 in there, so now I have $2 to myself. So the simplified version is 6y plus 2, and I'm done. I'm gonna go ahead and give you guys 1 minute to do practice 2 on your own, starting now. Once you finish your practice problem, message me the answer, or you can message it to the chat for everyone, either or. But I would recommend sending it to me in the chat. There you go. All right, so far so good, guys. The answers I'm getting from the people in the chat is correct. So if you said 7z plus 1, you're correct. Now that wasn't everyone's participation, guys, so I'm hoping you guys are online and participating and doing the work on your notebook. But it is 7z plus 1. Remember, when combining like terms, we only add the coefficients, not the exponents. Okay, guys, that's a different lesson, different topic. Everyone okay now with simplifying expressions using combining like terms? Any questions so far? All right, let's keep moving. Here's some examples. Simplify each expression by combining like terms. And this is example 3, example 4, and example 5. So I'm gonna go ahead and give you guys a minute to set this up into your notebook. All right, for example 3 class, 6y plus 12y minus 6. Which terms can we combine?
The 6y and the 12y.
Good, excellent, excellent. Put 1 underline under the y's because they can both be combined. And -6 is a constant term, so I'm gonna put 2 lines with this -6 to show which ones we can combine, which ones we cannot combine. It's a technique that I have. So Sarah was right, 6y, 12y can be combined, which gives us 18y. And bring down the -6 because there's nothing else to combine it with, and we are done.
What I do is like I put like a heart around some of them, or like a circle, or like a square.
Ah, you do different shapes. Okay, great, great. So that's a great technique. I'm gonna try it out for number 4. Okay, look at example 4. We have 4x plus 2 minus 5x plus 3. So there's underlines you can do, or you can do shapes like Sarah said. So I'm gonna go ahead and put a heart around the 4x and then a heart around the -5x because they're both x terms. And then I'm gonna go ahead and put a square on the +2 and a square on the +3 because they're like terms. Now 4x, was it a +5x or a minus? I can't even see right now.
It was a minus.
It was a -5x, right? So 4x minus 5x is -1x. +2 plus 3 is +5. And we're done. Now, another way to write this is that 1 can be invisible, so you can also say -x plus 5. Because the 1 is invisible. So they're both accurate, class. Now, let's look at example 5. 2x minus 5 plus 3y plus 4x minus 10y plus 11. So I'm gonna go ahead and switch it up real quick. So 2x, all the x's, I'm gonna put 1 line with the x's. And then 2 lines for my constant terms. And then 3 lines for my y's. And now we combine them, class. So combine the x's with the x's. So what's 2x plus 4x?
6x.
Good. 3y minus 10y. 3 take away 10. That's -7y. Minus 5 plus 11. I owe the bank 5, but I have $11, so now I only have 6 because I paid off the bank. And we are done. What questions do we have on combining like terms, guys? Any questions at all?
I did it from left to right, so my 6 is in the middle. Is that all right?
That is all right. That is definitely all right. There's not really like a formal final answer, right? Like where one is more correct than the other. That's a great question. So the question was that the 6 that she got was in the middle, not in my order. And the question was, is that also correct? Yes, you can write it as, you can do -7y plus 6 plus 6x. They're the same meaning, right? Now, if you want to be formal, right? The way, like if you want to have like a formality to it, you can, but it's not going to be right or wrong as long as you have the final answer right. But the formality would be alphabetical order. Notice that I did X, Y in order, and then the constant term is always typically last if you care about formality. But this course is not strict on formality because they mean the same thing. All right. Here are some practice problems, guys. I'm gonna go ahead and make this a little bigger. I'm gonna give you guys 4 minutes on these practice problems. Good luck. All right, about 15 seconds left, guys. If you are done, you can feel free to message your answers on the chat.
we sending all three of them or just the one for number 3?
All three, please.
Okay.
Excellent, guys. Excellent, excellent. Every answer that's been submitted so far has been correct. Good, good, good. Excellent, Sarah. Good, guys, good. You guys are getting more comfortable with CL. So CLT is a short word phrase to say combining like terms. And you guys are doing phenomenal so far. Excellent, Kimberly. Good, George. Good, Riley. Excellent, Priscilla. That is correct. Nicholas, take a look at your number 4. But your 3 and 5 are excellent. But look again at your number 4. Because what number is invisible from that plus y that we don't see? Oh,
1.
1, right? And how many y's do we have already?
1.
Well, we have 1, right? The plus 1y, but what about the start of the problem? What else do we have?
Oh, 7y.
So when you have 7 and another plus 1, what do we have in total?
8. Okay.
Good, so it'd be 8y. And then look at the numbers. 5, do you have $5 or do you owe the bank 5?
I owe.
And then plus 8, do you have $8 on you or did you spend 8 more?
You have 8.
So if you have 8 and you spend 5, what do you have left over?
3.
And then
Perfect.
yeah, so fix that, okay?
I just messed up on the minus and the pluses, but okay.
No, yeah, totally understandable, sir. Yeah. But this is the lecture, so this is the place to make mistakes, right? So we can talk about them, right?
Mhm.
So far, these are all wonderful, guys. Everyone's been correct so far. Are there any questions about any of these? So I'm gonna rewrite the answers for those of you that want to see the confirmation. So 3 is 18y minus 6. 4 is 8y plus 3. And 5 is negative 10x minus 9y plus 14. Now remember, order doesn't matter, but me, actually, like I've been doing mathematics for years now, for like 12 years now. So I have a different way of how I set it up for myself, but these are all correct. If we switch up the orders of these, you'll still be correct. Any questions so far? Yeah. And the only reason why, Joshua, because in my head growing up, I learned alphabetical order for terms. So like if you have an X term and a Y term, X goes before Y kind of thing, you know? Same thing whether it was like A, B, C, and I just do alphabetical order, you know? That's the way I learned it. Now, if you were to give me the Y first, you know, you'll still get it right, you know? I wouldn't take points off. You would have gotten full credit for it. Now, if a professor wants an order, they'll tell you, like, for example, let's say college algebra, they're like, I would like you to have, they'll let you know what they expect from you, okay? All right, let's keep going. So here's some more examples, guys. Example 6 and example 7. So here we're just gonna basically multiply. I'm gonna give you a minute to set these up in your notebook. Alright. So for example, 5 times 3y. So whenever we have a number multiplying by a variable term 3y, we just pretty much multiply the 5 and the 3 together. And 5 times 3 is 15, and the y is just tackled on there at the end. -2 times 4, a negative times a positive is a negative, and then don't forget the x as well. And we're done. So multiplying, we're just multiplying the numbers together and then keeping the x there. All right, let's go ahead and move on. Example 8. Now, we're gonna go ahead and be applying the distributive property now. So I'll give you a minute to set this up into your notebook. All right, let's take a look at example 8, class. So we're gonna use the distributive property, right? So the way you show distribution, class, is I urge you to draw an arrow from the number or value outside the parentheses and draw an arrow from the 5 to the x, and then draw an arrow from the 5 to the 4. Why? Because distribution says, excuse me, when applying the property, we're gonna multiply the number outside the parentheses to everything inside the parentheses. So for the example 8, we're gonna multiply 5 times the x, and then there's a plus sign there, right? Because we're bringing down the plus, and then we're gonna multiply a 5 times the 4 that was there. Now remember, there's different ways to write multiplication, right? The dot or the parentheses. Well, 5 times x, class, 5 times x is just 5x. 5 times 4 is just 20. And we're done. Example 9. Multiply -3 parentheses 5a plus 2. So we're going to be distributing the -3 right here to the 5a and then -3 to the 2. So how would that look like, right? So it's going to be a -3 times a 5a plus a -3 times a 2. So notice how the -3 went to the 5a, the -3 went to the 2, and the plus is still there, right? So -3 times 5a is -15a. -3 times 2 is a -6. But plus a -6 is just a -6. So rewrite that as a -6, and we're done. All right, example 10, we're gonna distribute the 8 now. 8, an arrow to the x, and an arrow to the -4. So 8 times x is just 8x. So in this one, I'm gonna skip the first step, right? Because we know we're just multiplying it out at this point. 8 times x is 8x. 8 times -4, a positive times a negative is negative. 8 times 4 is 32. And we're done. Any questions on using distribution right now? Any questions at all? All right, anyone need more time to write this down before I move on? All right, no one's asking, so I'm gonna go ahead and move on. Here's practice 8, guys, and practice 9 and practice 10. I'm gonna go ahead and give you guys about 5 minutes in total. I'll make it 4 minutes. I'll add a minute if you need more time. Good luck. All right, guys, let's take a look at the first practice problem. Anyone, y'all want to share what you guys got in the chat for practice 8? Excellent, Joshua. Anyone else? All right, so far so good. There was one mistake so far. So remember, when we distribute the 8, what operation do we do when we distribute, class? What's gonna happen to the 8 in the y and the 8 in the 2? Are we gonna multiply, add, subtract, or divide?
Multiply.
We're gonna multiply. 8 times y is 8y, and 8 times 2 is what?
16.
16. So make sure you understand that when we distribute, we're multiplying all the way through. All right, go ahead and put your answer for practice 9, guys. Practice 9. Excellent, guys, excellent. The answer is 21a minus 15. Good job, good job. All right, last one, guys, last one. How'd y'all do? Excellent, guys. 30 minus 6y. Good job. Any questions on any of the sets we took, class? Any questions at all?
Yes, I had a question for practice 8. So you don't turn the y to a 1, you just leave it as
You could do it into a 1. That would help you out to know to multiply the 8 with the 1, which gives us 8y. You can very much do so. It's not wrong to do it, and it's not wrong to not do it. You know what I mean?
Yeah, okay. Thank you.
Great question. Anyone else? Good, 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 good. All right, so now we're gonna do what we've been doing with distribution, but now we're gonna add some more difficulty to it. We're gonna have extra steps now. We'll go ahead and give you 1 minute to set up the first example. I'm gonna give you 2 minutes to write them out. You can skip like 4 or 5 lines for each one. You can do columns, however you want to separate your notebook. In 2 minutes, I'll begin working these 3 out. If you want to work one at a time, do one, and then once you finish that answer, box it in, then do the next one. You can. Not up to you. Like I said, this is your notebook. How you organize it is up to you. I just give you the information that you need to work on. All right. All right, class, for example, 11, what are we gonna distribute, class? What value?
The 2 times 3.
Yep, the 2 times the 3 and the 2 times the 7x. 2 times 3 is 6. 2 times 7x is plus 14x. Then bring down the minus 15. Use like terms to combine the 6 and the 15, which gives us 14x minus 9. And we're done. Any questions on the first example from 11? All right, let's take a look at the next example. The next one, which is simplify. Can anyone tell me how many different times would we apply the distributive property?
Twice.
Twice, right? The -2 to the x, the -2 to the -5, the 4 to the 2x, and the 4 to the 2. So -2 times x is -2x. -2 times -5 is a plus 10. +4 times 2x is 8x. 4 times 2 is 8. Class, are we done or can we simplify further? We can simplify further by combining like terms. I can combine -2x with 8x and then +10 with 8. So -2x plus 8x is 6x. 10 plus 8 is 18. And we're done. Last example here. We're gonna go ahead and distribute the -1. There's an invisible -1 here that we don't see for the third one, right? -1 times x is -1x or -x. -1 times +4 is -4. Bring down everything else. Combine the -1x and 5x, and then -4 with the 16. So -1x plus 5x is +4x. -4 plus 16 is +12. And we are done. Any questions on the steps we took, for example, 11 class? Any questions at all?
Yeah,
'Cause you
so
are
if you
gonna-
can, if
Go
you
ahead.
can combine it, you just bring it down.
Exactly. If you cannot combine, you just bring it down. If it's not being distributed, anything to it, then bring it down. You don't mess with it at all, okay?
Thank you.
No, thank you. You guys ready to try it out on your own? Some practice problems? Any questions before we move on? All right, here is your first set of practice problems on practice 11. I'm going to give you guys about 5 minutes here. Good luck. All right, anyone would like to share the answer for the first one for practice 11 on the chat or unmute? Excuse me. 10y minus 23 guys is correct. Good job. Any questions on the first one? All right. What about the second practice problem class? Excellent, guys. For those of you who got 3x plus 22, that is correct. All right, what about the last one, class? So we got 2y minus 13. You are correct. Now take row, be careful, George, you put 11. And I see it's because you have a +1 right here, right? But you're distributing a -1, sir. A -1 times a +1 makes it into a -1. And you're combining that with -12, right? So if you owe the bank $12 and you spend another dollar, you actually owe them 13 and not 11. Do you see that, George? All right. So far, so good, guys. I'm gonna go ahead and start a 5-minute break for now, and then we'll come back in 5 minutes. Okay, guys? See you guys in 5 minutes. All right, we're on 3.2, guys. The next section. I'm gonna go ahead and give you guys about 3 minutes or 2 minutes to set up the title and example 1. 2 minutes. Then we'll jump into it, okay? We're gonna be solving equations. We're gonna reviewing the addition and multiplication of properties. But now we're gonna add extra steps to what we've learned before, okay? The equations are gonna get a little bit more intense. All right, guys, let's take a look now. So now we're gonna be solving equations where we're gonna have to simplify one side versus the other side and then manipulate the equation to our benefit. So take a look at example 1. Y minus 5 equals -2 minus 6. First things first, I'm gonna draw the line down the equal sign, right? Well, the left side, y minus 5, I can just bring that down. Nothing gets combined there. But on the right side, -2 minus 6 can be combined. -2 minus 6 is -8. So now that I combine both sides, I simplified them, combining like terms. Now we can solve with the properties that we know. The opposite of -5 is +5. What we do to one side, we do to the other. That cancels out. We bring down the y. -8 plus 5 is -3, and we are done. Any questions on what we did in example 1, class? Any questions at all? I'm going to give you guys 2 minutes to work out the practice 1. Make sure your final answer is in the shape of an equation, x equals something, okay? Good luck. All right, guys. So what y'all get for practice 1? Excellent, guys. X equals -8. That is correct. Does anyone have any questions, comments, or concerns about practice problem? All right, you guys are doing pretty good. Let's keep going. Here is example 2 with multiple examples. I'll give you a moment to write these down before we get into it. I'll give you about 2 minutes to set it up, or a minute actually. I'll give you a minute. Alright, take a look at the first example. 3y minus 7y equals 12. Draw a line down the equal sign. Now, on the right side, there's nothing to combine to bring down the 12. But the left side, the 3y minus 7y, those are like terms. 3y take away 7y results in negative 4y. And then to get y by itself, remember they're being multiplied, right? The opposite multiply is division. I'm gonna divide both sides by negative 4. The 4's cancel, and I get y equals negative 3. And we're done. Any questions on this first one?
Why did we divide again?
Because remember, negative 4y is actually the same thing as negative 4 times y. And remember, to manipulate equations, we have to do the opposite. And the opposite of multiplying was division.
Thank you.
I'm gonna draw a line on the equal sign. Now, question, guys, can I simplify or combine the left side? Yes or no? If you said no, you're correct. Can I combine the right side, class? Can I combine 11 minus 5?
Yes.
Yeah, 11 take away 5 is 6. Now, can someone tell me what's going on with z and negative 4? They're being what? Negative 4 is being what to the z?
Multiplied.
Right now, it's not being multiplied right now. It's being what?
Oh, I'm sorry, divided.
Being divided, which allows us to
To
what?
multiply.
Excellent, sir. Thank you. So we're gonna multiply negative 4 on both sides. When we're dividing a negative 4 and then we end up multiplying, they're gonna cancel out. Bring down the z. And 6 times negative 4 is negative 24. And we're done. All right, we're on the last problem right now on the slide. So draw the line down the equal sign. Can I combine the right side? 7 minus 19. Are those like terms? Yes, they are. 7 take away 19 is negative 12. Now on the left side, you see that we can combine the 5x negative 4x. 5x take away 4x is just x or 1x. And we have the plus 2 still. To get x alone, I gotta subtract 2 on both sides. So then I get x equals negative 14. And we're done. Any questions on any of the steps we took? All right, there are no questions. Moving on. Here is another set of practice problems, guys. I'm gonna go ahead and give you guys about 4 minutes on these. Good luck. All right, guys, anyone have go ahead and type your solution into the chat for the first one. Don't forget, it has to start with M equals. Great job, Marina and Tanya. Awesome, awesome, Nicholas. Go ahead. Excellent, Riley. Excellent, Kayla Escobar. M equals -5 is the correct answer, guys. Good job. All right, let's go ahead and start typing in the solution for the second practice problem. Excellent, guys. Great job on the second one. Now let's go ahead and put our solutions for the last one. So y equals 20. All right, so I'm gonna go ahead and work out the first one for per request, right? So let's look at the first one. Put the line down the equal sign. Bring down the 10 because there's nothing to simplify there. But we can combine the right side, right? What's 2m take away 4m? If you have 2 and you spend 4, you're gonna owe the bank $2. So I have -2m. So let's look at here from here. Guys, how do we move the -2, guys? Do I add it, subtract it, divide it, or multiply it?
Add.
Nope. That's not the correct thing. Because look at what's happening with the -2 and the m. When they're next to each other like this, they're being what?
Multiplied.
Yes, and remember, operations have to be the opposite to move them around. What is the opposite of multiplying -2?
Divide.
Divide. And then what we do to one side, we do to the other. So -2's cancel out, so bring on the m. And then 10 divided by -2 is -5. And we're done. Let's look at the second one. I was asked to work out the second one per request. So I'm gonna draw a line on the equal sign. We can combine the left side, right? What's -8 plus 6, class? You owe the bank $8, but you gave them 6. So how much do you owe them now? -8 plus 6. The answer is -2. Bring down the equal sign, a over 3. Can anyone tell me what I'm gonna do to get rid of this 3? Am I gonna add, subtract, multiply, or divide?
Multiply.
Yeah, I'm gonna multiply by 3. What I do to one side, I'm gonna do to the other. The 3's are gonna cancel out, and which leaves us with a. 3 times -2 is -6, and we're done. Any questions on what we did for the first two? Well, y equals 20 was correct, guys. So the last one was good. Anyone have any questions for the third one before we move on?
I'm just still copying.
Okay. Let me know when you're good to go, sir.
Okay, I'm ready.
Excellent. All right, let's keep going. So now we have some more equations, guys. I'm going to go ahead and give you a minute to set these up into your notebook before I jump in. All right. Let's take a look at the left side example. Solve the equations. On the left side, 8x take away 9x. When we combine those two, what does that give us, class? 8x take away 9x.
Would it be negative X?
Yep, it'll be negative x, correct. And then we have 12 take away 17, which gives us a negative 5. Now remember, our goal is to have x by itself, but right now it has a negative in front of it. What number is invisible there that we do not see? Negative 1. So we're gonna go ahead and divide both sides by a negative 1. So then we get x equals a negative 5 divided by negative 1 is a positive 5. And we are done. Let's take a look at the second equation over here. Draw a line down the equal sign. What property am I gonna use to simplify the left side? What property does that look like to you, class?
Is it distribute?
Yep, we're gonna distribute. We're gonna distribute the 3 to the 3x and the 3 to the minus 5. So 3 times 3x is 9x. 3 times minus 5 is negative 15. And then bring down the 10x. Now remember, guys, the objective is to get x's by themselves. So I'm gonna go ahead and move, the numbers already here, 15's here, so I'm gonna move 9x over. So it'll be a minus 9x on both sides. Cancel that out. Bring down negative 15 equals 10 take away 9 is just x, 1x. So the answer is x equals negative 15, and we are done. Any questions on the algebra steps that we took this examples? Any questions at all? I'm trying very hard to expose you to many different scenarios with algebra. All right, moving on. Here are some practice problems, guys. I'm gonna give you 3 minutes on these. I'll add more if needed. All right, guys. Anyone want to share what they got for the first one? Remember how to write the solution, right? It has to start with the letter first. Go ahead and enter it into the chat. I see 14 and negative 14. So is it positive or negative 14? Let's find out. So on the left side, -4 minus 10, what do we get when we combine those two? -4 minus 14. We owe the bank 14. We spend 10 more dollars. So what do we owe them at the end?
-14.
Good, so bring that down. Now on the right side, 4y take away 5y. What does that leave us with when we combine those two?
-y.
-y. Now y is not by itself yet. So what do we do on both sides to get y by itself? What's
Divide.
invisible in front of the y?
Divide by 1,
Not just one though, what kind of one?
-1.
We divide by a -1, and what we do to one side, we do to the other. Those negative ones cancel out, so then we get y equals -14 divided by -1, which is +14. Are we all on the same page on why it should be +14?
Yes.
All right, go ahead and do this. Go ahead and share your answer for the second one, class. All right, you guys are correct. It is x equals -4. Good job. Are there any questions on what we did on the second one, guys? Any questions at all?
Can we work that one out?
Can we what?
Can we work that one out?
Yeah, we can. So the first thing first we do, the left side has nothing to do, right? But what do we do on the right side? What property?
Multiply.
Yeah, we're gonna multiply by distributing. 4 times 3x is what?
12x.
Good. What's 4 times -1?
-4.
Good. Now we want to move x's to one side. So how do I move a positive 12x to the other side?
Subtract 12x.
Subtract 12x. What we do to one side, we do to the other. 13 take away 12 is just 1x or x. What's left over? What do we bring down? The -4. And we're done.
Thank you.
No, anytime. All right, let's keep going, guys. I'll go ahead and give you a minute to set these up into your notebook. If you want to try these out on your own, as soon as you write them down, go ahead and get started. And then don't worry, it's an example, so I'll catch up with you. So take a look at the left equation, 2x minus 6 equals 18. Our objective is to get x alone, right? So draw a line down the equal sign. Now, whenever you have two things around the x, like a number next to it and then a number added, subtracted, you always want to do the subtracting or adding first. So like the numbers away from x, right? So that we're gonna move -6 first. So the opposite of -6 is +6. Bring down the 2x. 18 plus 6 is 24. Remember, 2x is just multiplying 2, so we're going to divide 2. Then we get x equals 12. And we're done. Let's take a look at the right side, the right equation. Quite the beast it is, right? So before we move on to the right side, let's touch on the left side. Can someone tell me what 2 take away 6 is? Excuse me.
-4.
Yeah, -4. I'm gonna go ahead and distribute the -5 to the parentheses. -5 times x is -5x. -5 times 4 is -20. Bring down the -39. Are there any like terms on the right side, class?
The 20 and the 39.
Yeah, what's -20 minus 39? We owe the bank 20, but we spent 39 more.
Is it -59?
Yeah. Now we want to get x by itself. So I'm gonna go ahead and add the 59 on both sides. So then I get 55 equals -5x. Divide both sides by -5. So I get -11 equals x, or x is equal to -11. And we're done. Has everyone seen how we're combining the properties we learned today? The distribution property, combining like terms, and then we're using the same steps we learned about solving equations, doing the opposite to move them around. So we've learned all, we've seen all these things already. Now we're just combining them to do a little bit more complex problems. Any questions so far, class? All right, let's go ahead and move on. I want you to go ahead and try these practice problems out on your own. I'm gonna give you all 4 minutes just because they get pretty intense.
Can you go back really quick? I wanted to see what was the answer for the last one.
Sure.
Okay, thank you.
No, you're good.
I'm good, thank you.
All right, let's go ahead and what did you get for the first practice problem class? Good, good, good. You guys got y equals 3. You are on the right track. Good job. Now, what about the second one? That's a more challenging one. The second one, Brianna? Yeah, definitely love to work it out. So first things first, draw the line down the equal sign. Let's do the left side first, right? So I'm gonna distribute the -4, right, by drawing my arrows. Guys, draw the arrows, please. Don't ignore those arrows. Those tells us what we're doing there. We're gonna do -4 times x, which is -4x. -4 times 2, which is -8. Bring down the -60 equals 2 minus 10. Now we combine like terms. 8 minus 60 is -68. And then I'm gonna do 2 minus 10, which is -8. I'm gonna add 68 on both sides. So then I get -4x equals, I owe the bank $8, but I deposited $68. So now I have $60. I'm gonna divide both sides by -4, which gives me x equals -15. And we are done. So we all got -15. Good job, class. Any questions so far on what we did in these practice problems?
No.
All right, let's move on. Now, you don't have to write this chart again because we wrote it already, but I do want you to write example 9. We're not writing the top part because we already have it in our notebook. We're just doing example 9. We're doing example 9. I'll give you about 2 minutes to work at these. guys, we're almost done, guys, with the lecture. Let's push through. All right, let's take a look at A. A number increased by -5. So what symbol do we use for the number? The number
X.
is X. It's increased by, which is addition, -5. But we know plus a negative is the same thing as just -5. So we're done with A. B, the product of -7 and a number. That's just -7 times X, which is just -7X. C, a number less 20. So it's a number that's less 20, so they get rid of 20 from X. D, the quotient is division, so it'll be -18 and a number. So this is the top one of the fraction, and then this one will be the bottom part. Now, E is the trickiest one because of the wording. A number subtracted from -2. So it's gonna be -2 minus X. And we're done with example 9. Anyone need more time to write down the answers and the problem for example 9? Would anyone like more time? Okay. Let's finish off strong. All right, this will be the last example, and then we'll be done with today, guys. Example 10. I'll go ahead and give you a few moments to write this one down. 2 minutes. Alright, let's look at A. Twice a number increased by -9. So A. When you have twice a number, that's just multiplying something times 2. So a number is x, so 2x. Increased by -9. 2 times x plus -9, which is the same thing as 2x minus 9 for A. B, 3 times the difference of a number in 11. So the difference of a number 11 is subtracting x minus 11. So times is the parentheses, right? So times is the parentheses. The 3 is right here. And then the difference of a number of 11 is x minus 11. Does everyone see how the color coding matches the statement? Let's look at C. The quotient of, so this is the 5 times the number is the top. So 5 times the number is the top of the fraction, 17 is the bottom. So 5 times the number is 5x over 17. And we're done. All right, guys, I'm going to go ahead and pull up the canvas so I can do some roll call real quick. So at this point in time, after right now's lecture, you should be able to complete homeworks 3.1 and 3.2.